In this series of videos, we want to work on developing thinking skills, in particular, mathematical thinking skills. However, since mathematics is the kind of a quintessential field in which analytical and logical thought processes get to be exercised and validated and tested, the kind of thinking skills that we develop when doing math are quite useful all around for just analytical thinking in general. So while watching these videos, you might think that we're doing lessons in math, which on one level we are. On another level, one of the main purposes for doing math is to develop our analytical thinking skills in general. Let me talk about how this, just a little bit about how this works. As a mathematician and math teacher myself, whenever I or others in the classroom teach mathematics, we teach algorithms, a step-by-step process of going from one point to another. 1, 2, 3 steps to get, for example, from some question to some answer. Now this is important to be able to have these algorithms as a tool for solving problems, but there needs to be something more. So often when I'm tutoring students one-on-one and talking with them, working through homework problems with them, the most common question I get is when students say, well, but what are the steps I'm supposed to do? I don't know how to solve this particular problem. I understood what the instructor told us in class, but I don't know what to do here because he didn't tell us the steps for this kind of problem. And usually what I end up telling them is, well, that's right. What you've got to do here is think. The instructor is not necessarily hiding information from you, not that they're trying to make your life difficult by not telling you the steps for this particular problem. It's just the reality of the fact is that there is no universal catalog for any problem that you will ever face in mathematics or in real life for that matter, a step-by-step process for how to approach it. You have to develop the skills of thinking in order to take the tools that you've learned and piece them together, just like a carpenter with his tools or an artist with his paintbrushes and chisels takes the tools that they've learned how to use, but then pieces them together and works with them to develop an end product. When I'm solving a math problem or doing math research, the process overall doesn't look like this nice, clean, linear model. Do you know what linear means? Linear, the root word line, is something connected by a straight line. So this algorithmic method of given such and such information, do steps 1, 2, 3, and you've got a straight line from question to answer, is a linear model. When I'm doing math research or solving math problem, it's highly nonlinear. If I'm given a question, I may think of a few different ways that I might go about trying to approach it, and as I work on one, I may find that it dead ends, and as I work on another, I may find that there's a couple different ways of proceeding from that route, and some of them will dead end, and another one I may find that I make a mistake. Oh no, yes, even professional mathematicians make mistakes. Yeah, but the important thing is learning how to realize when you're making a mistake and self-correct and go find another route. Sometimes, if I'm in pursuit of an answer, actually I say, well, what kind of information do I need in order to arrive at an answer, and how can I work backwards towards the information that I've been given? So sometimes I'm taking the information that I've been given and working towards an answer. Sometimes I'm going in the opposite direction. Or sometimes I start in the middle with what tools that I have. I say, well, I know I've got a tool for getting from here to here. How does that help me to bridge the gap from here to here? So in the process as a whole, it ends up being a whole lot of pieces, a whole lot of linear and nonlinear pieces mashed together, a lot of creative thought. Mathematics is a very creative endeavor and artistic science that in the process of a lot of indirect routes eventually ends up, hopefully, at getting where I want to be. The overall result being very different from the simplistic algorithmic model that you've learned in class. Now again, this is not contradicting the value of the methods that we learn in math classes and math textbooks, because these very clean, distilled, filtered, nicely structured and presented mathematical methods that we learn all come together to make up the toolbox or the tool chest that I'm using in the very messy nonlinear model. All these little pieces in here may be the algorithmic linear tools that I've used, but the process of fitting them together is very nonlinear and messy. So this is what we need to talk about and work on, is how do we develop the thinking skills that will allow us to take the toolbox that we've learned in the classroom and make the best use of it in order to actually solve the word problems and the real life problems and all of the problems in math that aren't structured as just straightforward application of plugging in numbers and being a human calculator, but requiring you to be an actual creative human who was made to think and be creative. How to piece all of those together in order to solve math problems, and then hopefully towards an even greater end of being able to solve the analytical and rational problems that you'll face throughout all of life, even outside of the mathematical realm.